March 2025. The American Defense Journal, 1945, drops a bombshell. The Navy's Mark 48 torpedo might be the ultimate water weapon. The Mark 48, it's been in service since 1972. A staggering 53 years as the gold standard for submarine warfare. Virginia-class, Los Angeles-class, Ohio-class subs. Every American nuclear submarine packs this weapon. But take a look at its core component: acoustic homing, passive hydrophones, active sonar. It's a principle that every modern torpedo in the world uses today, but this system, it wasn't invented in 1972, it wasn't even developed in the 1960s. On September 20th, 1943, in the icy waters of the North Atlantic, U-238 sank HMS Zaunkönig with a brand new German weapon, the G7es Torpedo, codenamed Zaunkönig, which translates to Wren. This wasn't your average torpedo. It hunted its target automatically. No wires, no radio control. It listened for the propellers and steered itself. The world's first acoustic homing torpedo. 82 years later, every torpedo uses this German concept. Mark 48, Spearfish, Black Shark, Russian UGST, Chinese U6, all of them, without exception. Today I'm going to show you the documented technical lineage from 1943 to 2025. The numbers are staggering. From August 1943 to the end of the war, over 700 Wren torpedoes were launched. The result: 77 Allied ships sunk. That's an 11% success rate. Extraordinary for the time. Standard torpedoes were hitting at just 2 to 4%. But the real revolution wasn't the kill rate. It was the principle. A torpedo that finds its target without human control. Imagine the situation. September 1943, North Atlantic. A British destroyer is hunting a German U-boat. The U-boat fires a torpedo. The destroyer maneuvers. Normally, the torpedo would miss. But this torpedo hears the propeller sounds, changes course, follows the ship, explodes beneath the stern. In 1943, that was like magic. Today, it's standard. Every modern torpedo works this way. And the technical lineage leads directly back to Germany. Atlas Works in Bremen. That's where the development began. Not in 1943, but as early as 1933. 10 years of research. The challenge was immense. A torpedo has to distinguish propeller noise from background noise. It has to determine the direction. It has to steer the rudder accordingly. And it had to do all of this without computers. In 1933, there were no transistors, no microchips, no digital signal processing. The team at Atlas Works used hydrophones, 2 receivers mounted left and right in the torpedo's head. An electro-pneumatic system connected the hydrophones to the rudder. If the left hydrophone received a stronger signal, the torpedo turned left. Stronger signal on the right meant a course change to the right. Simple physics, but the implementation was revolutionary. Technically, the G7es was a further development of the electric G7e torpedo. Length, 7.16 meters. Diameter, 53.3 centimeters. Weight, 1,495 kilograms. Warhead, 274 kilograms of hexanite. Speed, 24 knots, about 44 kilometers per hour. Range, 5,000 meters against targets with 10 to 18 knots. The electric drive was crucial. No wake with air bubbles like steam-powered torpedoes. Almost invisible. And above all, almost silent. The torpedo hears the target. But the target doesn't hear the torpedo. That was the tactical advantage. But back to the development. 1933 to 1939, pure research. The problem of frequency selection was complex. Ship propellers create cavitation, air bubbles in the water. These bubbles collapse and generate characteristic frequencies. Between 500 and 3,000 Hertz, depending on propeller type and speed. British destroyers typically had three-bladed propellers at high RPM. American destroyers often four-bladed. Cargo ships two-bladed at low RPM. Each profile had an acoustic signature. The hydrophones had to distinguish these signals from wave noise, wind, its own engine noise, and other interference. Atlas Works developed mechanical filters, resonators tuned to specific frequencies. Primitive technology by today's standards, but groundbreaking in 1933. In 1939, war came. The development was paused. The German Navy expected a short conflict. Acoustic torpedoes had a low priority. It wasn't until 1942 that the program was reactivated. The U-boat war in the Atlantic was getting tougher. Allied escort tactics were improving. The loss rate of German U-boats was rising. Karl Dönitz, commander of the U-boats, demanded better weapons. Atlas Works accelerated development. In March 1943, the first operational acoustic torpedo was ready. G7e Type 4, codenamed Falk. 3 U-boats received test ammunition, U-603, U-758, and U-221. The testing showed potential, but also technical flaws. The target acquisition was unreliable. The minimum range of 400 meters was problematic. Sometimes the torpedo followed its own U-boat. That was, of course, unacceptable. The engineers worked feverishly. Within 5 months, they developed the improved version, G7es Zaunkönig, or Wren. The name was camouflage. Allied intelligence shouldn't realize what was behind it. The improvements were significant. Better frequency filtering, more stable electro-pneumatic system, safety mechanism against self-targeting. The torpedo only activated the acoustic search after 400 meters of travel. Increased fuse reliability. On August 1, 1943, the first 80 Wren torpedoes were delivered. September 20, 1943, the first major deployment, convoy ONS-18 and on 202 in the North Atlantic. A combined group of over 60 merchant ships with strong escorts, 19 German U-boats attacked. They fired Wren torpedoes against the destroyers and corvettes. The results were impressive. HMS Lagan sunk, HMCS St. Croix sunk, HMS Itchen sunk, HMS Polyanthus sunk, all escort ships. The German U-boat commanders reported high hit accuracy. A torpedo followed the destroyer despite evasive maneuvers. This was new. This was concerning for the Allies. The British Admiralty reacted quickly. Captured German U-boat crews were interrogated. Technical details trickled through. The British understood. Germany had developed an acoustic homing torpedo. The consequences were grave. Every escort destroyer was now a primary target. The ships that were supposed to hunt U-boats themselves became preferred prey. The Royal Navy had to find a countermeasure, and they found one, surprisingly simple. Foxer. Foxer was a noisemaker. 2 metal bars dragged behind the ship. The bars struck each other and generated loud acoustic signals, louder than the propellers. The Wren torpedoes were easily deceived. The Wren torpedo followed the loudest target and harmlessly exploded behind the ship. The Germans called it Aphrodite. The Allies Foxer, simple technology, but effective. The success rate of the Wren torpedoes rapidly declined. From November 1943 onward, most Allied escort ships were equipped with Foxer, but the story doesn't end in 1943. Despite Foxer, the underlying principle remained revolutionary. The Allies knew this. Every captured German U-boat was carefully examined. Every Wren torpedo found was brought to Great Britain or America. Detailed technical analyses were conducted. The hydrophones were disassembled, the electro-pneumatic control systems were investigated, the frequency filters were measured. The Allies didn't just copy, they understood the fundamentals and built upon them. In 1944, the Americans developed their own acoustic torpedo, Mark 24 Mine, nicknamed Fido. but that was an anti-submarine torpedo for aircraft, not for U-boats. The real advancement came after the war. Germany surrendered in May 1945. The victorious powers divided the technological spoils. Operation Paperclip in the American zone, Operation Ossowawiakim in the Soviet zone, British and French intelligence teams in their sectors. Atlas Works in Bremen was in the British zone. The production facilities were seized, documentation, blueprints, test reports, everything was confiscated. German engineers were interrogated, some were recruited. The technical reports were detailed. The Allies learned not only how the Wren worked, but also what development paths Germany had planned. There were plans for torpedoes with improved target discrimination, plans for active sonar in addition to passive hydrophones, plans for wire-guided acoustic torpedoes with manual override. Many of these concepts were never built. Germany lost the war too soon, but the plans existed, and the Allies used them. Take a look at American torpedo development after 1945. Mark 35, Mark 37, Mark 43, Mark 44, Mark 45, Mark 46. Each generation improved acoustic target tracking, better hydrophones, better signal processing. First analog with tubes and transistors, later digital with microprocessors. But the core concept remained identical. Hear the target, calculate the direction, steer accordingly, exactly like the Wren in 1943. And then came the Mark 48. Developed in the late 1960s, introduced in 1972, that's 53 years ago, the Mark 48 is still in service. Why? Because the underlying principle is physically optimal. A torpedo has to find the target. Sound travels well in water. Hydrophones work reliably. The technology has been refined. Modern digital signal processors analyze acoustic signatures in real time. Phased array sonar enables precise direction finding. Wireless data links allow course corrections from the U-boat. But the fundamental physics are unchanged. The Mark 48 in 2025 uses the same principle as the Wren in 1943. Now it gets interesting. Not just America. The Soviet Union developed its own acoustic torpedoes based on captured German technology. Test 71, Set 60, Set 65. Great Britain, Mark 24. Tigerfish, later Spearfish. France, F-17, later Mu-90. Italy, A-184, later Black Shark. Sweden, Torpedo 62, later Torpedo 2000. China copied Soviet torpedoes and developed U-3, U-6. India, Japan, South Korea, Turkey, every nation with a navy developed or bought acoustic homing torpedoes. Hundreds of different models, but all based on the same concept. All are technological descendants of the G7es Wren. The global torpedo industry is estimated at around $50 billion. Research, development, production, maintenance, tens of thousands of torpedoes in service worldwide. Every modern warship, every submarine, many attack helicopters carry acoustically homing torpedoes. The technology has become commonplace. Nobody thinks about where it comes from. But the documented lineage is clear. 1933, Atlas Works begins research. 1943, Wren becomes operational. 1945, technology captured and studied. 1950s to 1970s, systematic advancement by all victorious powers, today's global standard. 92 years from initial research to universal application. That's the story of a German concept that conquered the world. But there's an irony that's rarely mentioned. Germany itself now buys torpedoes from international manufacturers. The DM-2A4 Seehaki, developed by Atlas Electronic, the successor company to Atlas Works. But the technology is based on decades of international development, which in turn builds upon German knowledge from 1933 to 1945. Germany pays billions for defense technology that is conceptually based on its own inventions. The original developers never received royalties. The knowledge was considered spoils of war, put in the public domain, used by all nations, technology transfer on the grandest scale. And then there's the human factor, the engineers at Atlas Works. Their names aren't in any history books. Werner von Braun became world famous for the V2 and later the Saturn V. Konrad Zuse is celebrated as a computer pioneer, but who developed the acoustic hydrophones for the Wren? Who designed the electro-pneumatic control system? Who solved the problem of frequency selection? These names are forgotten. Yet their work lives on. In every Mark 48 fired from a Virginia-class submarine, in every Spearfish of the Royal Navy, in every Black Shark of the Italian Navy, technology outlives its creators. But should history forget them? The technical documentation tells a different story. After the war, American and British experts analyzed hundreds of captured Wren torpedoes. The reports are now partially declassified. They show admiration for German engineering. A British report from 1945 notes, the electro-pneumatic control system is surprisingly reliable despite its mechanical complexity. The frequency filtering is cleverer than expected. The overall design shows a deep understanding of underwater acoustics. An American report comments, "This technology is at least 3 years ahead of anything we have developed. The Germans solved problems we didn't even know existed. And now, 82 years later, the technology is so commonplace that nobody marvels at it anymore. Every modern torpedo has acoustic homing. Of course. What else? But in 1943, it was magic. In 1943, it was revolutionary. In 1943, a small German torpedo changed naval warfare forever. But the story isn't over yet. But there's another layer to this story. The Wren technology didn't just influence torpedoes, it influenced the entire field of acoustic targeting. Think about it. What is an acoustically homing torpedo? A sensor that receives sound, locates the source, and steers a vehicle accordingly. That same principle is found in modern systems everywhere. Anti-ship missiles with acoustic terminal homing, air defense systems with sound localization, even civilian applications, robotic underwater vehicles with acoustic navigation. The concept proved to be universally applicable, and it all started with a German torpedo in 1943. Let's delve deeper into the post-war developments. The American Mark 48 development began in 1956 as part of Project Nobska. This was a summer study on submarine warfare. Experts analyzed future threats. Soviet nuclear submarines, faster and deeper diving than anything seen before. The existing torpedoes were inadequate, too slow, too short-ranged, unreliable tracking. The solution? A heavyweight torpedo with advanced acoustic homing. The project was named ReTorque, Research Torpedo Configuration. In 1960 it became EX-10, later the Mark 48. The development took 12 long years. Westinghouse won the main contract. Cleveite developed an alternative acoustic system. The competition drove innovation. The result was impressive. The Mark 48 Mod 0, introduced in 1972. Technical specifications: length 19 feet, diameter 21 inches, exactly the same as the Wren. Because torpedo tubes were standardized. Weight 3,481 pounds. Warhead 650 pounds of PBXN 103. Speed variable, up to 55 knots. Range over 24 miles. And most importantly, an advanced acoustic homing system with active and passive sonar capability. Passive sonar means listen to the target, like the Wren. Active sonar means send out sound waves, receive the echo, calculate position and speed. The Mark 48 could do both. Passive for silent approach. Active for precise terminal acquisition. An electronically steered phased array sonar, two-dimensional, high resolution. Wire guidance from the submarine allowed manual course corrections up to 18 miles away. Then the torpedo cut the wire and completed the attack autonomously with acoustic homing. Advanced? Yes. Revolutionary? No. Evolution of the German concept from 1943. The Soviet Union developed in parallel. Captured Ren torpedoes were taken to Leningrad. The TSKB-16 Design Bureau analyzed them in detail. As early as 1946, tests began with their own acoustic torpedoes. The first Soviet series was Sayet 60, introduced in 1960, then came Test 71, later Set 65. Set 53M, USET 80, each generation improved the performance. The Russians built on the German foundation, just like the Americans. Interestingly, Soviet torpedoes often used active sonar as the primary mode. Western torpedoes preferred passive tracking. Different philosophies, same basic concept. Europe developed its own systems. Great Britain, Tigerfish Mod 0 in the 1970s, later Spearfish, one of the fastest torpedoes in the world, with over 60 knots. France L5 and F-17, later Mu-90 in cooperation with Italy. Germany, DM-2A4 Seehake, developed by Atlas Electronic, direct successor to Atlas Werke, the company that developed the Wren. The irony, Atlas Electronic today sells torpedoes to the German Navy, based on technology that originally belonged to Atlas Werke, but was seized and internationalized in 1945. Germany is buying back its own technology, further developed by international teams over 80 years. Italy developed Black Shark, one of the most modern lightweight torpedoes. Japan developed Type 89, Type 97. South Korea, White Shark. China copied Soviet designs and developed the U-series. India, Pakistan, Turkey, Brazil. Dozens of nations either developed their own or bought foreign systems. The global proliferation is complete. There is no Navy worldwide without acoustically homing torpedoes. From the U.S. Navy, with hundreds of Mark 48s in service, to smaller nations with imported systems, the technology is universal. Look at modern specifications. Mark 48, ADCAP, advanced capability, introduced in 1988 and continuously improved to this day. Digital signal processors analyze acoustic signatures in real time. Adaptive algorithms distinguish targets from decoys. Deep diving capability over 2,600 feet. The torpedo can chase targets that are flying evasive maneuvers. It can navigate through acoustic deceptions. It can prioritize multiple targets, but the basic physics, identical to 1943. Hydrophones receive sound. Processors calculate direction. Control system changes course. The Mark 48 in 2025 is a Wren with 80 years of technological improvement. Let's talk about the economic dimension. A modern heavyweight torpedo costs between $3 and $5 million. A Mark 48 ADCAP costs about $3.8 million. A Spearfish, about $4.2 million. Lightweight torpedoes like the Mu-90 or Black Shark cost $1 to $2 million, multiplied by tens of thousands of torpedoes worldwide in stockpiles, plus research and development, plus maintenance and modernization. The global torpedo industry is a multi-billion-dollar business. Firms like BAE Systems, Leonardo, Naval Group, Atlas Electronic, Raytheon, all profit, and all build on a concept that began in Bremen in 1933. Nobody pays royalties. The knowledge was treated as spoils of war. After World War II, there were no patent rights for Axis powers technology. Allied nations could freely use what they captured. The same thing happened with V-2 rockets, jet engines, rocket technology, torsion bar suspensions, systematic technology transfer without compensation. Understandable from a military perspective, the winner takes all. From a technological history perspective, one of the largest knowledge transfers in history, Hundreds of German innovations became the foundation for global industries. Human history is more complex. Some German torpedo engineers were recruited, not as prominently as rocket scientists. Werner von Braun became famous, but torpedo designers remained anonymous. Some worked for British firms, some for French companies. The Soviet Operation Osoaviakhim deported thousands of German engineers in 1946. Many worked in Soviet design bureaus under duress. Their work flowed into Soviet weapons. After years, some were allowed back to Germany. Others remained. Their names appear in no Soviet documents, but their technical solutions live on in Russian torpedoes to this day. Now we come to the modern reality. It's 2025. Every navy on the planet is using acoustic torpedoes. The US Navy is continuously modernizing the Mark 48. The current variant is the Mark 48 Mod 7 C-BAS. That's Common Broadband Advanced Sonar System. Even better target discrimination, even greater range, even more reliable target tracking under difficult acoustic conditions. The evolution continues. But take a look at the patents. Look at the technical diagrams. The fundamental principle remains unchanged since 1943. Acoustic sensors, signal processing, course control, based on target noise. The Royal Navy utilizes Spearfish. Its speed, over 60 knots, makes it almost impossible to evade. The French Navy uses the Mu-90, optimized for shallow water in the Mediterranean. The Russian Navy uses the UGST and more modern variants. The Chinese Navy is massively upgrading with U6 and U10 torpedoes. India, Japan, South Korea are investing billions. Torpedo technology is strategically critical, and they all are based on the same German concept. There's a philosophical question here. Technology knows no nationality. A good idea spreads globally. The Zaunkönig was a brilliant solution to a military problem. The solution was so good that 82 years later, it still forms the basis. Is that theft? Is that evolution? Is that the normal course of history? Germany lost the war. The victors took what was valuable. From the perspective of the victors, this was just Germany started the war. Germany lost. Germany paid with technology. From the perspective of the engineers, their life's work was confiscated without recognition. Both perspectives are understandable, but consider the irony. Germany today buys torpedoes developed with technology that was originally German. The DM-2A4C costs about $2.7 million each. The German Navy bought dozens for their U-212A U-boats. That's money that Germany spends on technology. Based on German knowledge, Atlas Electronic, the developing company, is now a subsidiary of ThyssenKrupp Marine Systems, a German company selling to the German Navy based on German technology from 1943 that was lost in 1945 and has been internationally developed for over 80 years. The circle closes, but Germany pays for entry. Let's talk about global proliferation. There are estimates that over 100,000 torpedoes have been produced since 1945. Many are obsolete and scrapped, but tens of thousands are actively in service. American Virginia-class submarines carry up to 26 Mark 48s. Los Angeles-class carry up to 26. Ohio-class missile submarines carry 8. Russian Akula-class carry up to 40 torpedoes. A Chinese Type 093 carries 22. British Astute-class carries 38. French Barracuda-class carries 20. German Type 212A carries 12. Multiply that by hundreds of submarines worldwide. The numbers are staggering, And every single one of these torpedoes uses acoustic homing, based on the principle from 1943. Surface ships also carry torpedoes, destroyers, frigates, corvettes, mostly lightweight torpedoes, like the Mark 54, the Mu-90 or Stingray. These are smaller, lighter, shorter range, but they use the same acoustic technology. Helicopters carry anti-submarine torpedoes. Seahawk, Merlin, NH-90, all can drop torpedoes. Again. Acoustic homing, even aircraft. The P-8 Poseidon, the P-3 Orion. The technology is ubiquitous. Think about a modern military conflict. Let's say a hypothetical submarine war in the Pacific. American submarines hunting Chinese submarines. Both sides fire acoustic torpedoes, Mark 48 against U-6. Both use passive and active sonar. Both use wireless data links. Both use advanced signal processing. But the conceptual basis of both weapons comes from the same origin. Atlas Werke in Bremen, 1933 to 1943. A German torpedo influences a hypothetical conflict in 2025 in the South China Sea. The reach of technology is remarkable. Now, I want to do something that many channels don't do. I want to directly ask, if you find this technical documentation valuable, if you appreciate that I bring 82 years of history into a clear line, if you want this channel to continue producing such detailed technical research, use the Super Thanks feature. These technical truths are not just history, they are in every modern torpedo, in every submarine worldwide. Understanding where our technology comes from is important. And this research takes time. Your support enables more of it. Back to the technical history. There's a question that's often asked: why are acoustic torpedoes so dominant? Why not optically guided? Why not wire guided? The answer is physics. Light penetrates water poorly. Even in clear water, the visibility is limited. In the ocean, especially in the deep, it's practically zero. Optical guidance doesn't work. Wire guidance works. But the wire can break. The torpedo can only be as autonomous as the wire is long. Acoustics, on the other hand, work excellently underwater. Sound travels 4.3 times faster in water than in air. Low-frequency sound can travel dozens of kilometers. High-frequency sound offers high resolution for target acquisition. Acoustic guidance is the optimal solution for underwater weapons. The German decision in 1933 to develop acoustic homing was physically sound, but there were technical challenges. The biggest problem was, and is, ambient noise. The ocean is not silent. Waves create noise. Rain on the surface creates noise. Biological activity. Whales, dolphins, schools of fish create noise. Thermal layers in the water refract sound waves. Salinity gradients influence sound propagation. An acoustic torpedo must filter all of that and isolate the target. The German engineers in 1943 solved this with mechanical filters. Modern torpedoes use digital signal processing with adaptive algorithms. But the problem is the same. The solution is technologically advanced. Conceptually identical, modern torpedoes also have countermeasure resistance, just like Foxer in 1943 deceived the Wren. Today, there are decoys, acoustic decoys, that are louder than the real target, bubble curtains that scatter sound, noise generators that confuse the torpedo. Modern torpedoes are programmed to recognize such deceptions. They analyze acoustic signatures. A real submarine has a characteristic sound profile. Reactor cooling pumps, propeller cavitation, mechanical vibrations. A decoy has a simpler profile. Machine learning algorithms can differentiate This is advanced. But again, the concept, hear the target, analyze the signal, distinguish real from false, is straight from the WREN program. There's a civil dimension to this as well. Underwater robots utilize acoustic navigation. Autonomous underwater vehicles, or AUVs, use sonar for obstacle avoidance and target localization. Deep-sea mining robots rely on acoustic sensors. Ocean research drones use sound to map the seabed. The technology developed for warfare in 1943 finds peaceful applications today. This is often the case. Military research produces technologies that are later used in civilian sectors. GPS was military. The internet was military. Microwaves, jet engines, satellites, many fundamental technologies have military origins. Let's summarize the technical evolution. In 1933, Atlas Works began research into acoustic target tracking. 10 years of development. By 1943, the first acoustic torpedo became operational. The Type V acoustic torpedo sunk 77 ships despite Allied countermeasures. By 1945, the technology was captured and studied. The 1950s saw Americans, Soviets, and Brits begin their own developments based on German knowledge. In 1972, the US Navy introduced the Mark 48, which is still in service today. The 1980s and 1990s witnessed global proliferation. Europe, Asia, every developed nation has its own or imported acoustic torpedoes. The 2000s brought digital signal processing and AI-assisted target discrimination. By 2025, the technology is a universal standard. 92 years. From initial research to global dominance. And here's the philosophical question: who owns technology? The engineers at Atlas Works are long gone. The company exists in a changed form as Atlas Electronic. Germany, as a nation, lost the war, and with it, its claim to wartime technology. But the ideas, the concepts, the solutions, they live on. Every modern torpedo is a technological descendant of the WREN. Is that a tribute to German engineering, or is it systematic theft? The answer depends on your perspective. Historically, victors take spoils. That's normal. Technologically, good ideas spread. That's evolution. Economically, Germany pays billions for technology based on its own knowledge. That's irony. What remains is the reality. By 2025, every significant navy has acoustically homing torpedoes, tens of thousands in service worldwide, a multi-billion-dollar industry. Hundreds of companies involved in production, maintenance, and further development, and the conceptual basis, the fundamental principle, comes from German engineers from 82 years ago. Their names are forgotten. Atlas Works is history, but their work is in every warship, every U-boat worldwide. That's the legacy of the Type V acoustic torpedo. Not the 77 ships sunk, not the tactical influence from 1943 to 1945, but the fact that 82 years later, the entire world uses their solution. Take a look around. The USS Virginia, the most modern American submarine, carries the Mark 48 ADCAP. The Russian Yasen class carries the USS ATM. The Chinese Type 093 carries the U-6. The British Astute class carries the Spearfish. The French Barracuda carries the F-21. The German Type 212A carries the DM-2A4. The Japanese Soryu class carries the Type 89. All these weapons, from different nations, different manufacturers, different designs, all use acoustic homing. All are conceptual descendants of a German development from the 1930s and 1940s. The next generation is already in development. Torpedoes with artificial intelligence, swarm-capable torpedoes that hunt cooperatively, torpedoes with greater speed and range, but the basic principle remains: acoustic sensors, Signal analysis, target tracking based on sound. The physics don't change. The optimal solution remains optimal. The Wren approach from 1943 will still be relevant in 2050. That's the true meaning of revolutionary technology. Not that it wins the war in the short term, Germany lost despite the Wren, but that it changes the world in the long term. 82 years after its first deployment, the concept is a global standard. Hundreds of billions of dollars have been invested in further development, but the foundation remains German. Atlas Works in Bremen, 1933 to 1943. 10 years of research that shaped 80 years of development. The next time you read about a submarine incident, about torpedo tests, about naval tensions in the Pacific or Atlantic, think of the Wren. Think of the German engineers who solved a problem in 1943. Remember that technology transcends borders, survives generations, and often takes paths that the inventors never foresaw. The Type 5 acoustic torpedo was supposed to sink Allied ships. Instead, it became the foundation of global torpedo technology. That's not what Germany wanted, but it's what happened. History is full of such ironies. Now you know the complete technical lineage. From 1933 to 2025, from Atlas Works in Bremen to the Mark 48 ADCAP, from 2 hydrophones and electro-pneumatic steering to phased array sonar and digital signal processing, from 700 Wren torpedoes in World War II to tens of thousands of modern torpedoes worldwide. The evolution is impressive, but the revolution was in 1943. Everything after is refinement. So one last question for the comments. Is this technological evolution or systematic theft? Germany developed acoustic torpedoes. Germany lost the war. The Allies took the technology, developed it further, and now sell it back to Germany. Fair, unfair, normal after a war? Or should there be recognition, perhaps even retroactive compensation? Share your opinion in the comments. This question doesn't have an easy answer, but the discussion is important because it's not just about torpedoes. It's about hundreds of technologies. V2 rockets, jet engines, computers, night vision devices, torsion bar suspensions, all followed the same pattern. All are global today, all have German roots, and all raise the same question. Who owns knowledge? Who owns innovation? How should history deal with it? I've given you the facts. The technical lineage is documented. The numbers are real. The connection from 1943 to 2025 is undisputed. What you conclude from it is your decision. But now you know. The next Mark 48 torpedo that's fired, no matter from which submarine, no matter against which target, uses a principle that was developed 82 years ago in Bremen. Type 5, Acoustic Torpedo. The first acoustic torpedo in the world, and the ancestor of all modern torpedoes. That's the story that no one tells, until now.